Hello, in this video we are going to look at implementing vertex input description. So far when we draw our triangle, so if I run it, it'll go through the validation layers first, so it'll take a few seconds. Then our colorful triangle will appear. I know why that's not appearing. We can I do want to show you the triangle. So I know why it's not appearing. It's because I updated the shader file. So let me just get the older shader files that you will have on the. I made the mistake of changing them, but not recompiling them. And so, okay, so if I copy all of that and paste them into here, replace, boom, there we go. Give it a run. That should now show the triangle. Give it a run again. That's strange. Let me just disable validation layers. It's clogging up on validation layers for some reason. Okay, there we go. So that is now running. Don't know what was happening there. So we're all good to go. We can continue. So I'll leave the validation layers disabled for now. Actually, now we will need them. Make sure they're working. Okay, they're all working again now. Okay, there we go. So with the vertex input description, this is going to be part of the vertex buffers section, and this is going to be a few videos. This will allow us to, instead of creating this triangle using hard-coded position values, because if we open up our shader files, so these are the shader files, and we want to edit these too. So let's just drag them onto our favorite text editor, and we'll edit the vertex shader first, because we put the color here and the position values right inside of our shader file. We're going to make it dynamic so we can pass those values into our shader files, and that way we can draw any sort of triangle with any sort of color that we want. So we still need the output of the frag color, but we don't need this anymore at all. And what we're going to use is put a layout, put a location of 0. It's fine if it's the same as this one, for the simple reason this is going to be an input vec2 in position, and for another layout, location equals 1 in vec3. So this is going to be the color. And for the position, what we're going to put now is in position, like so. And we've just put 0.0 there because that's the 3D value, so the Z axis. We're not dealing with 3D at the moment. And for the frag color, that will get passed into the fragment shader. We're going to put in color. Save that. Now in the frag shader, what we want to do, we still, do we even need to change anything in here? So we've got the frag color, we've got the output color, and honestly, no, we don't. We're actually all good to go. We don't need to change anything in our frag shader. So I'll leave these open just in case I've made a mistake and I need to edit them. But what we're going to do is recompile them. Remember, feel free to go back to the video where I compiled it and look at the different ways of doing it. I'm going to do the easy method and just drag it onto here. You'll pump out a a.spv, so that's the frag one. So I'm going to get rid of the existing frag shader, compile shader I should say, and do that. Do the same for the vertex one. and get rid of this one and rename this to vert. There we go. So we've got all the shaders edited and compiled now. We need to add some code to actually make use of this. First of all, we need to include a new library, glm/glm.app. Though we have not used GLM yet, we actually set it up in the setup video. So if you did follow the setup video and you've been following along in this course, then you won't really have any issue in terms of GLM, but you got to make sure that it is set up. Next thing, we need to include the array header. And next, what we're going to do is create a vertex struct. So if we go down here just before our class, I'm going to create a struct called vertex, and this is just going to contain the vertex information. And we could use this for stuff other than triangles, because really this is just going to be saying we're going to have a position and a color. There's a few other things that we need to do in terms of binding and attribute descriptions, but again, they're just relevant to, they're related to a vertex, not a triangle. So this is very dynamic. So I'm going to say glm : vec2, pause for position, glm : vec3, color for color. Just move the mic there a second to get it better in view. I'll make it a bit higher. There we go. And now what we are going to do is tell Vulkan how to pass this data format to the vertex shader once it's been uploaded into GPU memory. So I'm going to put static vk vertex. So it's going to return a vertex input binding description, and don't need semicolon. And here we're going to have a vk vertex input binding description, curly braces, and this is actually meant to be called get binding description. That was a mistake on my part there, sorry about that. And now I'm going to say binding description dot binding equals 0, binding description dot stroid equals size of vertex, binding description dot input rate equals vk underscore vertex underscore input underscore rate underscore vertex, semicolon. I'm going to say return binding description. Now we're going to description. I forgot the P there. That error should go away now. And okay, so now we're going to describe how to handle the vertex input in the vk vertex input attribute description that we've just done right here. That's sorry, in the attribute, sorry. So that's the binding we're going to handle the attribute description. So I'll say static std : array. This is the header that we included earlier. vk vertex input attribute description, comma 2, get attribute description, and we're going to say std : array vk vertex input attribute description, comma 2, because there's going to be two pieces of data, the position and the color. And I'm going to call this attribute description. You want curly braces for this bad boy right there. And now what we're going to do is tell Vulkan which which binding for the per vertex data comes. So for the binding for this is going to be 0. So attribute description 0 dot binding equals 0. Not bidding, binding. And next we're going to reference the location directive of the input in the vertex shader. Remember we did it over here, location 1, 0 and 1, because this is going to be the position stuff that we're doing. It's going to be 0 first, so we're going to put attribute description. Doing spelling mistakes all over the place today. 0 dot location equals 0. Next we're going to describe the type of data for the attribute. So attribute description 0, and we're going to say dot format equals vk underscore format underscore r 32 g 32 underscore s float. And I'll put description for the simple reason that's where I've got it set in the code itself. Put descriptions there as well, to be fair. That's where I've got it set in the code that I've got on GitHub. I'd rather keep it as consistent as possible, so if you're looking at this you are seeing the same stuff. Next we're going to set an offset, and this specifies the number of bytes basically since the start of the per vertex data to read from. So attribute descriptions descript. Yeah, my spelling is so bad today. Descriptions dot offset equal offset of, and we specify vertex, and then we're going to put the pause right here. So there we go. Next what we are going to do is copy and paste all of this, and we are going to change this to 1. Binding is still 0, location is 1, the format is almost the same, and we're going to put RGB. And just because, I mean, the naming convention is similar to like colors, but that's not what it is. So just, you can almost ignore that. So we got an extra piece of data because we got 3 for color and RGB, hence why we've got 3 here. And we're going to say color for this. I'm going to do a return of attribute descriptions. And we are almost done. We got a couple more things to do. First of all, we're going to create a vector of vertices. This will represent our triangle. So const std : vector. This will look very familiar to what we did in the vertex shader and the thing that we removed today actually. Equals, there we go. And here, so this is going to be the format, and we're going to say negative, no, 0.0f, negative 0.5f, 1.0f, 0.0f, and 0.0f. So that is the color. And I'm going to copy and paste this, so we got multiple instances of this. 0.5f, 0.5f, 0.0f, 1.0f. For this we'll do 1.0f there, so it'll be red, green and blue, and you'll just interpolate the colors. And for this it's going to be negative 0.5f and just positive 0.5f. Okay, so we're almost there. We're gonna go to the create graphics pipeline method implementation, and in there we just need to do a bit of referencing, and this will essentially be referencing the binding and attribute descriptions. So you want to go to where we've got shader stages and vertex input info, and after this we're going to start our code. We're going to set up the graphics pipeline to accept vertex data in this format by referencing the structures. So we're going to say auto binding description, I think I spelled it correctly this time, equals vertex get binding description semicolon auto attribute description equals vertex get attribute descriptions semicolon. So these are the methods that we created earlier on. We're going to say vertex input info dot vertex binding description count equals 1. So we're going to put vertex input info dot vertex attribute description count, and this equals static underscore cast unsigned int. I'm going to put attribute description dot size, and we want this to be attribute description. I keep making this mistake. And almost done. We're going to put now vertex input info dot p vertex binding descriptions equal a reference to the binding description, and we're going to put vertex input info dot p vertex attribute description equals attribute description dot data. So we are giving the data into there, and we're good to go. We can give it a run, see what we get. Those errors should hopefully disappear. I know my computer needs a restart. We got no errors, and triangle will not appear once we've done all this. We're getting a few errors. That's fine, because we're going to fix all of these errors over the next few videos. And yeah, so that's it for the vertex input description. We've come a long way. Again, it's still moaning for some reason. Since the Visual Studio being Visual Studio, because again, it did run successfully, may I add. There we go. Even though that was the same thing. So that is it. If you have any questions, feel free to join the Discord group. There's a link in the description. There's a Vulkan channel on there. Over 5,000 members now, so I look forward to seeing you in there. There's a link in the description to the GitHub page, which has the source code from this video, every other video, and working solutions that you can just load up and run to the state that I have them in that video. And I look forward to seeing you in the next video.